All right, in this lecture, we're going to learn about Python scripting for the operating system. And what's going to be contained in here is basically to give you an idea uh, how to do a lot of tasks that typically in the past historically would have been done with a bash script. In the past, you couldn't count on Python being shipped with a Unix operating system, but that's not true today. It's pretty much standard to be shipped on any system that you'll find, and if not, it's very easily installed. And because of that, it's going to be my choice and my recommendation for writing anything more complicated than just a few lines of bash, because I think you'll find that the syntax is a lot friendlier, especially once you start doing looping constructs and other things. And basically, anything you can do in bash, you can do in Python, typically a lot simpler, a lot more readable, and then of course you have the full power of the whole Python language, so you can do a whole lot more in the end. So we'll start with just something really simple. You can basically write a Python script, and just like a bash script, a Python script will have a shebang line and should look like this right here. And then you can call any Unix command from a Python script by first importing the sum process module, and then you'd use that by saying subprocess, and then one of the functions that's a member of subprocess module is a function called call, and then you can just type in the exact Unix command that you would use. So in this case, ls-l. So obviously, to replace 3 lines of Python code with something you can do very easily from the command line, ls-l, is not that productive. However, you're going to see the utility as we move on to a little bit more complicated things. So just to show you, here's the same script that I have in the slide there, and in the Python script. And if we run that, ls py, okay, and we get the same answer, okay? So this is where the utility of Python starts to show up, and its ease of looping or also conditional statements like if. So here we can loop over a multitude of Unix commands. In this case, only 2 that I'm showing here, but there could be more. And the easiest way to do that is to simply place them in a Python list like this. Okay, so a Python list is dynamic, so it can be list of strings combined with integers combined with real numbers. And in this case, we just have a list of strings that we're then going to loop over. And of course, in Python, we'll use an iterator for that, namely this command. So we use the syntax for command in commands. What that's going to do is, as it loops over this list, you're going to each time command will be replaced with that string, and then subprocess will be called on it. And so in this case, we can loop over those 2 commands, and I'll go ahead and show you what that looks like. So I have the file here. It's the same as the slide. And if we run that, you see at the top, it first echoes a listing of the directory, and then it performs the ls-l. So this kind of offers a way to start converting any bash scripts that you may have into Python scripts by simply assigning them to variables and then looping over them if it's just a sequence of commands like that. Of course, we still replaced what you can do in 2 lines of Unix with 10 lines of Python or whatever, which is not very productive. But as we move to more complicated things, so we can create functions very easily in Python. Here the syntax is a little bit nicer than if you were to try to create a bash function. And what this function actually does is it takes the base name of a file. Say in this case, if we had a file called test.1.png, and we wanted to make that into a file called new.1.png, then we'd run this function on it. So the function change name takes as an argument the old name and then the new base name. And so what that does, this first line here, splits the old name based on the period. So it'll split test.1.png into a list containing test, 1, and then png separately. Okay, and then we're going to just simply concatenate 1 and png with the new base name. So the new base name plus a period plus temp1, which would be in this case 1, plus a period plus temp2, which in this case would be png. And then what we're going to do is call the the module call, and move the old name to the new name. So this is basically just a base name renaming utility, and then down here we just call the function. Okay. So if we look in the home directory, or in my directory here, you'll see a file called test.1.png. So if we run the change name script, which is exactly like it is in the slide, you'll see that test.1.png has been changed to new.1.png. Okay, so again, not terribly interesting, but we're going to add some functionality, and this is how we kind of put it all together. So here we're going to define a couple of functions. The first function is just a function that's going to run a bash command, but this time instead of just printing the output, it's going to actually pipe the output to standard out, and then once it's been piped to standard out, we're going to take it and split it. We're going to take it and split it into a Python list based on the line endings. So for every line that's output to standard out, they would be put into a Python list. Okay, and so that's what that first function does. The second function is exactly the one we just covered. It basically takes a base name and changes it with a new base name. So then the last function, change all names, we're going to first run bash on ls, so it'll print a listing of the files in the directory, pipe that listing into a Python list, and then we're going to loop over that list with this command. So for a file in files, which comes from here, we're going to loop over that, and every time we're going to then change the name, the base name, if and only if the base name matches the old base name. So in other words, we don't, if you know, in this particular case, you'll see in a second, there's files in my directory that I don't want to change because they don't match, the keyword test. So basically, it's probably time to move over for an example. First of all, I have a script that'll create a bunch of dummy PNG files. So you can see I have in my directory there a bunch of PNG files, and this happens a lot when the output of simulations or something. You may get kind of files numbered like this, and for some reason you may want to change the name of them. So while I want to change all the files named test.30.png or whatever, I don't want to change any other names, any other files in that directory. So basically using this script here, which I called change all names. This is the same script that's again from the slides. At the end, I'm going to call change all names with the input test. So I want to change any file with the base name test to a file with the base name new. And so if we run that, you see all the files that were named test have now been renamed new. So this is I'm basically listing the directory, finding all the files that were named test something, and replacing that with new, concatenated with whatever it was before. So you can see this becomes here's where a little more utility is. We wouldn't want to rename all those files one by one. Okay. So the next thing we can do to add some a little bit more utility to our functions is to add arguments. So there's a really nice module in Python called argparse, which allows us to add input arguments or command line inputs. And so this code right here at the top basically just adds a parser such that when I run this file from the command line, now I don't have to, as you saw before, I don't have to hard code the call to change all names. Now I can accept inputs, say test and new, from the command line itself, which makes my function a little more a little easier to use. So what's in the middle here is basically everything from the previous slide, and then finally when we call change all names, we're going to use the arguments that we parsed up here. Okay, so an example then here would be a new script that I've called batch rename.py. So here you see the argument parser at the top, and followed by the same three functions from before, and the final call to change all names. Okay, so I'm going to remove those new files, and let's create a new set of dummy PNGs. Okay, and so now we can run this batch rename.py with changing test to new. Okay, and you see that happen. So let me remove those again, create them one last time. Okay, and just to show you that it does work instead of you. So if we want to change test to something different, so let's just say something. I'm sorry. I need to run the file. There you see they've been changed to something. So if we remove those one last time. Okay. So next, this was actually quite easy because the way the files were named, the period actually made it very easy to split them. However, we can also do it if we didn't have something so obvious as the period to split the file names apart. We could do it with regular expressions as well. So now I'm importing basically the same function, except I'm importing a module RE, which stands for regular expressions. And then the only difference between this and the other code is when I split, instead of splitting on a period, I'm going to split based on one or any occurrences of digits. Okay, and the parentheses here around the regular expression, here and here, indicate that I want to actually return whatever I split into my list. So this is going to return a list, namely with the base name, whatever your split criterion is, and then whatever's the file extension or whatever's left. If we didn't have the parentheses there, it would actually omit the digits themselves and just return the base name and omit whatever the digits that you're trying to split. And since we want them to reconcatenate them to our new string, we want them to remain. So I encourage you to play around with that. But anyway, basically the only difference between that and the previous file is how we're splitting it. So I split it there. I split the string here as well. So let me go ahead and give you an example of that as well. So if we had a bunch of files that this time don't have a dot to say, so now the dot between test and the number is gone, it makes it a little more difficult to split them, so we have to use these regular expressions, which, if we take a look, I have another file called batch regular expressions.txt. Oh, sorry, .py. All right. So there is the This is the same file from the slide, the output from the slide. So then if we just run batch regular expression, and then we still have the argument parser in there, so we're going to change test to new, say, RE. And there you see, new RE and the number concatenated. All right, so these are the kind of things you can do with a Python script. You know, really there's nothing that I did here that you couldn't also do with a bash script. However, I would argue that the Python is probably, you know, a little bit more syntax concise. And in my opinion, good code is at first readable code so that other people can use and extend it easily. And Python is certainly a little bit more readable than bash. So in the performance area, they're probably about equivalent. And you know, I think you should know a little bit of bash scripting for just the most basic things. But as your scripts become more and more complicated, especially if you're doing any kind of computations in them, I think you're going to find that Python scripting is a lot easier, a lot more extensible, and probably better for what you're trying to do. Thanks.